In this video, I want to give you some intuition as to why this infinite series converges. And remember, converges means that this infinite series narrows in on a particular number. Even though it is an infinite sum, the infinite sum gets closer and closer and closer as you go out to the terms to some particular number. So to gain this intuition, I'm going to first draw a box here, or maybe a rectangle. Okay, so let's say that the dimensions of this rectangle are 2 by 1. All right, so this infinite series n equals 0 to infinity, 1 over 2 to the n. Remember, this is 1 over 2 to the 0, so that'll be a 1, plus 1 over 2 to the 1, that'll be a half, plus 1 over 2 squared, that's a fourth, so plus an eighth, plus a 1/16, and so on. All right, so first let's look at this 1 here. This 1 here, right, this is 1 here. Right, the area of this piece right here is 1, right? Because, right, let's see, it's half of 2. I just cut the rectangle in half. So the length of the entire rectangle was 2, so the length here is 1. And its height is this 1 right here. So 1 by 1, it's 1. Okay, so that means that this side over here, right, this side over here is also, the area is also 1. And so now 1/2. So we'll cut this in half here. So the area of this piece right here is not 1, oops, what am I thinking? Is 1/2. Like so, right? So remember the original whole piece, right? This original whole piece here, right, was 1, so I cut it in half, so then I have a half, so then that's why the blue area is a half. All right, now looking at this piece here, right, cut this in half, this is a quarter. Right, and then this part here, that's an eighth. Right, so that's an eighth. Like so. Well, I'm running out of colors now, but in any case, I think you get the idea, right? Cutting this in half there is 1/16. And continuing on like that, right? Maybe that's not the quite, let's put it right here. So then you have like that. That would be 1 over 1/32, and then 1/64, and then 1/128. And you can see that I'm just narrowing in closer and closer and closer to 2. So this infinite series here, right, let's see, this was 1 plus a half plus a fourth plus an eighth. We can see that this thing narrows in on 2. So its limit is 2. Now this is also consistent with what we know about these types of infinite series. This is a geometric series. And we could rewrite 1 over 2 to the n as 1/2 to the n, so that r is equal to a half. Now remember that geometric series that converge, right? And this one does in fact converge, right? Because remember, geometric series converge if r is between -1 and 1. So this does in fact converge. And it also and we also have a formula for what it converges to. This thing converges to 1 over 1 minus r. All right, so let me give myself a little more room here. All right, so we can see from the box example, or the rectangle, that intuitively it should converge to 2. And we also know it is a proven fact, proven by mathematicians, that this thing converges to that it converges to 1 over 1 minus a half. So let's see, what is 1 over 1 minus a half? Let's see, that's 1 over, so 1 minus a half is a half, right? That's 1 over a half, which is 2. So we see that, in fact, the proven result does have intuition, and that is this whole rectangle idea.